Now you are going to learn about how to model this standard nut design. Look at it, looks like a simple model, but we need to know some of the important area while designing. Let's start from designing. New part design and select a top plane to create a sketch. Initially I choose a polygonal profile and make it into a 6 different kind of a sides. Hexagonal sides. Okay, once I draw the profile, look at the exact dimensions for this portion is 18.48. This dimension is under the limit for 2 different kind of an endpoints. Before that, I just selected all that endpoints and use the vertical geometrical constraints to fix it. Once you fix it, use the dimensions to give the dimensions of 18.48 mm. Okay, now the profile is fully defined. Let's make it into a solid model. Okay, what is the exact thickness of the solid part is 8.4 mm. Now we are not applying any kind of a hole at this condition. Let's make it into a solid model using extrude boss options. Exit the sketch now, then using extruded boss options to make it into a solid body. The thickness is 8.4 mm. Okay, once the solid formation is done, now I change the appearance to make it into much brighter than that. Then use hole wizard options and select position, choose the particular face which you want to create a hole and select the center of its origin point. Once the origin point is selected, next we are going to change the dia. In the drawing, the dia is M10, so make it into a bottom taping hole under the options and select the standard dia M10. The depth is not limited, it is completely forms entire the solid formations. The M10 thread for entire solid body. Select through all options or any kind of options you want. Through all means up to the end portions of this initial solid part. Okay, now the model is almost created. Next we are going to make a thread formations, or before that we need to make a chamfer also. First I select a chamfer. Okay, let's make a thread formations at this conditions. Before applying a thread, if you are not using a chamfer in these conditions and applying a thread formations, okay, selecting the circular edge and choosing a end limit up to selections, up to this end selections. What is our standard thread type? Metric tape, and the thread type is M10. Choose M10 and into 1 mm pitch. M10 into 1 mm pitch. This is our standard thread formations. If you are applying a thread formations without applying any kind of a chamfer at this 2 different kind of a circular edges, it is initially forms like that. After applying a chamfer formation in this condition means you cannot able to create it, because whenever we apply any kind of a thread formations, we need to know or applying chamfer before the thread formations. Now the selection is up to the end selections and the thread formation is cut thread. In these conditions, I am choosing a cut thread option, not extruded thread option. Extruded thread is only applicable for a shaft faces. Cut thread is applicable for a hole or otherwise internal features. In these cases, if you are using a chamfer at this condition, you cannot able to apply it properly because the circular edges is not completed within each other. If you selecting the circular edges, the chamfer formations are not done properly. Look at it, the chamfer formations are not done in either both directions, direction 1 and direction 2. In any cases, both the circular edges, look at it, this circular edge are not complete within each other because it is completely under the formation of thread. Let's get into rollback method and apply a chamfer before that. Select a chamfer. Now the angle, 120 degree angle, and the distance, 0.5 mm distance. Then choose the circular edges in both the direction. Now I change the direction. Okay. The chamfer formation is done. Then roll forward it. Afterwards, look at it. Our thread formations have some kind of errors. Just select it and edit the features and change the circular edges patterns. Now I select the circular edges at the entire portions. The up to selection is same as like that. And apply the thread formation. The whole thread formations is now easily created. M10 is the standard dia with 1 mm pitch. Next we are going to make this sharp edges. If you apply any kind of a chamfer positions or using a vertex chamfer means we cannot able to create it because we don't know the exact distance for it. The initial dimensions are only given as 0.58. If you are playing either selecting edges or vertex, we cannot able to create it properly. Instead of that, we are going to use one shortcut method to form the taper formations at both ends. Selecting any one plane, but it shows the 3 different kind of faces at one initial scale. If I am selecting a front plane, look at it, only 2 different faces are shows, but I want 3 different faces at one initial plane. Look at it, this is the correct formations. Let's draw the profile. Same as like our chamfer profile. Once the profile is drawn, you're going to use a smart dimensions or a construction line because I'm going to make a revolve cut. That's why I'm selecting a right plane, but the faces must be 3 different kind of faces or lies at one single plane. Okay, 0.58. This is the correct operations. Instead of giving angle, look at it. There are mentioned a 130 degree of angle. If I am giving like that, it will not make it into a proper chamfer formations at these conditions. So let's change the selection process and apply it. Look at it. It is only mentioned 74 mm. If I am changing any kind of an edges and giving an angle means we cannot know what is the exact angle we need to do in these conditions. Overall angle, it is not possible under these cases because the total angle is 180 degree. From the axis, the angle must be divided by 2. So it is called 130 divided by 2, 65. So selecting the line profile as well as the endpoint, the quadrant is created now. Line, endpoint, the quadrant is created now. Then the angle is 65 mm. This is the exact shape of it. Then use the revolve cut options to make a cut at 360 degree completely. Look at it, the outer sharp edges only cuts. This is how the nut formations are easily done at all different kind of edges. By removing the all different edges. If you use a chamfer or any kind of filler formations, you cannot able to done properly. Okay, let's make this cut at both end directions. Again draw on a horizontal center line at this particular midpoint. Then use the mirror entities to select this overall profile. In mirror about, select this horizontal construction line and mirror both the curves. Look at it, this is the exact operations are done by using of a revolved cut options. The important portion is that chamfer portion. Okay. Thank you.